Salam, everybody. Welcome to Physics with Noshir, and we're discussing this paper. And let's start off with the first question, where they're asking you to design an experiment where you're going to measure EMF and change the speed of the falling magnet. So let me show you the diagram. The diagram looks like something like this, where you have this coil जिसके अंदर EMF इंड्यूस होगा, जिसके ऊपर आप वोल्टमीटर साथ कनेक्ट करोगे EMF इंड्यूस मेजर करने के लिए. Magnet will be released from a certain height. Magnet गिरेगा, magnet का magnetic field इसको कट करेगा, आपको मालूम है. An EMF will be induced and the voltmeter is going to measure that EMF induced. Now, to measure the speed of the falling magnet, what you need to do is you need to measure the height through which it falls. So we're going to measure the height from this point all the way till the end of the coil. And to measure the time, we need the stopwatch. So there's no need for a fancy stopwatch. You can just make a box, and the maximum that you could do is you could just do this, and write seconds. So that would give us an idea that you're trying to measure time. Now, how do you start this experiment? You write defining the problem. And in defining the problem, you define three things: the independent, the dependent, and the control variable. Independent variable क्या होता है? ये वो variable होता है which you will vary in this experiment. तो आप क्या vary कर रहे हो? आप speed vary कर रहे हो. You're varying the height due to which the speed is going to vary. So your independent variable is going to be V. Your dependent variable is going to be EMF because EMF depends on your change. So dependent variable वो होता है जो आपके change पे dependent होता है. Basically जो आप y-axis पे लिखते हैं. And the number of turns in this experiment are kept constant. Why? Because if you change the number of turns in the middle of the experiment and you don't change the height, voltmeter reading will change. And we don't want that. We want a relationship between the voltmeter reading and the height. We do not want anything else to be changing the voltmeter reading. So therefore, keep the number of turns constant. Now, the method of data collection is how you will perform the experiment. So the first thing is they check that have you made a very well labeled diagram, and the answer to that is yes. Then you explain how you will do the experiment. Magnet is dropped from a height using a stand. The height is adjusted to vary the drop speed. Voltmeter connected to the coil is used to measure EMF induced. Speed is determined using height over time. Height is measured using meter rule. And time is measured using the stopwatch. Now, in the question, they said that it is predicted that EMF induced is directly proportional to the speed. Hence, based on that, you should say that we will get a straight line passing through the origin. EMF is on the y-axis because this was dependent. V was independent, hence on the x-axis. And you have to give the statement that if the relationship is valid, it will be a straight line passing through the origin. Remember this, that in all graphs in paper 5, you will always make a straight line. Even if it's an inverse relationship, you will make a straight line. You'll just know exactly what I'm saying in the next question that we do in this paper. Additional detail. Now, in additional detail, you can measure safety. 1 mark for safety in this experiment. And 3 or 4 other points which can help us improve this experiment. How are you going to take repeat readings? Very important. So you use a large number of coils, so EMF induced is large. Remember, I said do not change the number of coils. I did not mention the number of coils. So you always use a large number of coils so that your EMF induced is large, so you can at least read it off from the voltmeter. अगर number of coils बहुत कम होंगे, उसकी वजह से EMF induced कम होगा, तो आपका voltmeter reading नहीं आएगी. Secondly, use a vertical non-metallic tube. Now, why are we using a non-metallic tube? Why aren't we using a metallic tube? Because if you use a metallic tube, तो उस metallic tube के अंदर EMF induce हो जाएगा. And that will be troublesome because then the voltmeter reading would not be accurate. So, therefore, use a non-metallic tube and wrap the coil around it. Then, the guide tube should be held vertical with a clamp stand. So, we're saying that this coil, it's very difficult to make the coil vertical, right? So, usko aap ek tube ke ird-gird लपेट लो, tube के इर्द-गिर्द बांध लो, and make sure that the tube is vertical, and you could make another stand if you want to, or you could just leave it and just write that point like I have written over here, that we will use a stand to ensure that the guide or the tube is straight. And then use a cushion to catch the magnet. Repeat the experiment for each speed or drop height and average the EMF or the voltmeter reading that you get. Remember that in additional detail, you have to give improvements. You have to tell us how are you going to repeat the experiment, और अगर कोई रीडिंग में वेरिएशन है तो उसको रिपीट करके एवरेज करना है. So repeating the experiment is very important. And then in any reading in which you think that there is some variation or some possibility, तो उसको repeat करके average करना होता है. Luckily, इसके अंदर repeating और average वाली कोई चीज़ नहीं है. You just have to repeat the experiment so you get multiple values of EMF with speed. And then you can make a graph. While I was saying that, एक point आया ज़हन में which you could possibly write, which is that you repeat the experiment, you repeat the experiment for same height and get the average time, because time mein, when you're measuring from a stopwatch, you could have that error, and then get the average speed. So any way that you can improve the accuracy and the precision of the experiment will be accepted. For example, precision better करनी है, stopwatch की जगह light gates use कर लो. You can use light gates connected to a timer box, but usually light gates are technical, and then a lot of people don't want to explain that, so therefore you can use stopwatch. Stopwatch का फिर तरीका समझा दो और ये लिख दो कि जी एवरेज टाइम कैलकुलेट कर लेंगे और उस एवरेज टाइम से हम एक एवरेज स्पीड निकाल लेंगे. Question number 2 is another experiment in which it is suggested that the strength of the magnetic field at the center of the flat coil, is inversely proportional to the radius. So they're saying that B should be inversely proportional to R. This is what you need to test from this experiment. So हमें किसी न किसी तरह radius vary करना है of the coil, and then we have to measure B. Now remember, to measure B, you always have the Hall probe. Now the setup looks something like this. So you have your coil, and you've connected the coil to a power supply, a switch. The Hall probe is kept at the center because they said that the Hall probe should be at the center. And guess why am I making this vernier caliper over here? The reason is I need to measure the diameter from where I can calculate the radius of the coil. And then in the experiment, what I'll do is I'll use different radii. I'll change the radius, measure the radius, and then with that new radius, I'll have, let's say, a smaller coil. I'll put the Hall probe in the center, measure the Hall voltage again. Hall probe से आपको जो reading आएगी, उसको आप convert कर दोगे B के अंदर, because you know that Hall voltage is proportional to the magnetic field strength. So the higher your Hall voltage, the higher will be this reading B. And you don't have to explain any of this because this is not paper 4, although you should know. इसलिए हम हमेशा हॉल प्रूफ के साथ एक पॉइंट लिखते हैं, वो मैं आपको दिखाऊंगा एडिशनल डिटेल में, वो आपने याद रखना है. Defining the problem. Radius is going to be the independent variable because that is something that we will change. The magnetic flux density is going to change as a result of that. The number of turns must be kept constant because, like I said, if the number of turns change, then the strength of the magnetic field could change. And also in this experiment, because using a power supply, तो जाहिर है करंट भी आ रहा होगा, तो करंट को भी कांस्टेंट रखेंगे. अब आपकी मर्जी है that you want to put current as your constant or your control variable over here, or you want to put the number of turns. If you have multiple controls or multiple things which you want to put as constant, then please write any one of them in this heading, any one of them, doesn't matter. And the rest of the controls can be put in the additional detail. That's what additional detail is for. All other things that you want to put constant can be put in additional detail. Method of data collection ke andar, you will say the diameter of coil is measured using vernier caliper, like I explained, and the radius is going to be diameter divided by 2. Now, Hall probe measures the field strength at the center of the coil. How do you determine where is the center of the coil? That's the question. So the center of the coil is determined using the Hall probe reading. So you should know कि जब आप coil के center में आओगे तो Hall voltage वहाँ पे maximum होगा because field lines की concentration सबसे ज़्यादा होती है उस point पे. So center of coil determine करने का खाली ये तरीका नहीं है, और भी तरीके हो सकते हैं. You could, let's say this is a coil. You could say, जी, we measure the diameter in 2 directions and made the center. That's one way. The easier way is you already have something which is reading off. So let's say ये आपका Hall probe है, तो अगर Hall probe यहाँ पे रखोगे reading कम आएगी. But if you put your Hall probe over here, your reading will be very high. So wherever your Hall probe gives the highest voltage, that is the center of the coil. A DC supply is connected to the coil to produce the magnetic field, and the Hall probe measures the magnetic field. Again, if you look at the marking scheme and you feel कि मेरे points का flow और marking scheme का flow same नहीं है, doesn't matter. It should make sense to you. They don't particularly check that, okay, in the marking scheme, if something is mentioned in method of data collection, has this kid mentioned the same thing? No, they don't check it like that. They'll read up your entire write-up and then they will compare it with the marking scheme and say, okay, he's missed this point, इसने ये वाला point miss किया, इसने ये वाला point miss किया. For example, अगर मैं ये वाला point यहाँ पे ना लिखता and I had written this point in additional detail, I would have gotten the mark. Remember this. So please remember to make it easy for yourselves. Paper 5 is easy and really scoring, inshallah. Analysis. Now, I told you earlier that you always make a straight line. Remember? But they had given an inverse relationship. So what do? You make a graph of B versus 1 over R. Because if B is inversely proportional to R, then you should know that B is directly proportional to 1 over R. So we make a straight line and say, if the relationship is valid, it will be a straight line passing through the origin. Additional detail. Use a large number of turns, like I explained earlier in the question above as well, that it creates a strong magnetic field. Keep the current in the coil constant. That's a constant, a control variable. Use protective gloves to avoid hot coils contact with the hand. Hall probe must be calibrated in a known magnetic field. So I was telling you that you should know how we convert the Hall voltage to the value B. But for paper 5, you don't need to know that. All you need to do is you need to give this statement that the Hall probe must be calibrated in a known magnetic field. इसका मतलब क्या है? इसका मतलब ये है कि भाई आपको हॉल वोल्टेज को एक नॉन मैग्नेटिक फील्ड के अंदर कैलिब्रेट करना चाहिए. मतलब ये कि एक नॉन मैग्नेटिक फील्ड फॉर एग्जांपल है 1 टेस्ला का. इसमें आप हॉल वोल्टेज नोट कर लें. लेट्स से हॉल वोल्टेज आता है 5 मिली वोल्ट्स फॉर एग्जांपल, जस्ट पिकिंग अप फिक्टिशियस नंबर्स. Now, when you put this Hall probe in the middle of the coil in this experiment, और ये Hall probe आपको दे देता है reading of 0.25 millivolts, would you be able to tell what is the value of X? Absolutely. This is called calibration. So this is called calibrating the Hall probe in a known magnetic field. That is why this point is so important. And you can skip all of the theory that you need to know for paper 4 just by writing this one beautiful statement. Now, repeat the measurement for radius and average. Like I said, जिस भी चीज़ में variation हो उसको average करें. And how do you repeat the experiment? Repeat the experiment with the Hall probe reversed and average. Remember, when you reverse the Hall probe, you'll get the same reading. You should technically get the same reading. But if there's slight variation, you can still average and get the average Hall voltage and then use that and find the magnetic field strength. I hope this is clear and best of luck.